Physicists have just completed an experiment that proves light travels in both space and time. And you're probably thinking, wait a minute, doesn't light always travel in space? Well, not exactly. You see, light is an electromagnetic wave, and it's been proven to travel at the speed of light, approximately 186,000 miles per second in space. But what about time? We all know time is relative. Einstein taught us that much. But does that mean light travels at different speeds at different times? Well, it turns out the answer is yes. This groundbreaking experiment has revealed that light can move at different speeds depending on the time at which it's measured. And it's got scientists excited because it could lead to some pretty cool future tech, like new materials that can control how light moves through them. But there are also some quantum implications here that could change how we do telecommunications and computing. Before we get into the details of this experiment, let's talk about why scientists are excited about it. The study was conducted by researchers at the University of Vienna and the Austrian Academy of Sciences and published in the journal Nature Photonics. They used a technique known as attosecond transient absorption spectroscopy to measure how fast light travels through a medium called rubidium vapor. Attosecond, by the way, is a unit of time equal to 1/quintillionth of a second, or 10 to the negative 18 seconds. In other words, it's incredibly short. Scientists have been able to generate pulses of light lasting just a few attoseconds, which are so short that they enable us to observe extremely fast phenomena, such as the behavior of electrons in solids or the dynamics of chemical reactions. So the team fired a 30 femtosecond laser pulse at the rubidium vapor, where femtosecond is 1/millionth of an attosecond. Then they measured how long it took for the light to pass through the vapor and came up with some surprising results. First, they found that the light moved faster than expected when it entered the rubidium vapor, but then it slowed down after passing through a certain distance. The researchers say that when the light pulse enters the rubidium vapor, it causes the atoms in the medium to oscillate, which creates a temporary refractive index that slows down the light. As the light travels through the medium, the refractive index changes over time, which affects the speed of the light. But here's the kicker. They also found that the speed of light changed depending on the time at which it was measured. Specifically, the researchers found that the light moved faster at earlier times, but then it slowed down as time went on. They were able to model this behavior using a mathematical equation known as the nonlinear Schrödinger equation, which describes how the refractive index of a medium depends on the intensity of light passing through it. The equation takes into account the fact that the atoms in the medium are not point-like particles, but rather have a finite size, which leads to a delay in the response of the medium to the incident light. This delay, in turn, causes the light to travel slower at later times. Now, why is this important? Well, it turns out that this behavior of light could be put to good use in future technologies. For example, researchers believe that it could be possible to create new materials that can control the speed of light passing through them, which could lead to the development of ultra-fast optical switches for use in telecommunications or computing. Additionally, a better understanding of how light interacts with matter could help us develop new ways to transmit data optically, potentially leading to faster and more efficient communication methods. But that's not all. This experiment also has some implications for our understanding of the quantum world. See, in the quantum realm, particles can exhibit properties of both waves and particles, and light is no exception. In fact, one of the most famous experiments in quantum mechanics. The double-slit experiment demonstrates the wave-like properties of light. When light is sent through to slits, it creates an interference pattern on a screen behind the slits, which is a hallmark of wave behavior. However, if we try to measure which slit the light is going through, it stops doing that wave Y thing, and instead comes out looking like a regular old particle. This is known as the observer effect, and it's one of the key features of quantum mechanics. Now, the researchers didn't set out to study quantum mechanics in this experiment. They were just trying to understand how light behaves in a medium, but their findings could help us learn more about the observer effect and other quantum phenomena. For example, by studying how the speed of light changes in a medium, we can learn more about how quantum entanglement works, which is a correlation between two or more quantum particles that allows them to influence each other instantaneously, regardless of the distance between them. We can also learn more about quantum superpositions, which is a state in which a quantum particle exists in multiple states at once. These are the basic principles behind quantum computing, by the way. So yeah, it's pretty cool stuff. So that's just a brief overview of what this experiment found. If you want to dive deeper into the weeds, I encourage you to read the original paper. It's not too technical, so anyone with an interest in science should be able to understand it. If you want to stay up to date on all the latest scientific discoveries, be sure to subscribe to our channel. We cover everything from breakthroughs in astronomy and physics to advances in technology and medicine. We're constantly expanding our content, so there's always something new to learn. And while you're at it, be sure to check out some of our other videos. We think you'll really like them. For example, there's this video we did on black holes that got millions of views. Or what about this video on dark matter? Yeah, those are pretty good. We also have a video on string theory that's gotten a lot of attention lately. No. And if you want to see something really cool, check out this video we did on the James Webb Space Telescope. So take a look around, find something that interests you, and learn something new. And hey, if you really like what we're doing here, consider supporting us. It helps us keep making great content for everyone. Now back to the video. One of the most exciting things about this experiment is the potential for future applications. By understanding how light behaves in different media, we can develop new technologies that control the speed of light, which could lead to faster and more efficient communication or computing. Here are a few ideas that researchers are already exploring. First, we could create new materials that have a nonlinear refractive index, meaning that they change the speed of light passing through them based on the intensity of the light. This could lead to the development of new optical switches that could be used in telecommunications or computing. For example, we could create a switch that uses light to control light, which would be much faster and more efficient than current electronic switches. Second, we could use these materials to create new types of lasers that emit light at different speeds, which could be useful for a variety of applications, including in medicine for things like photodynamic therapy, which uses laser light to destroy cancer cells. Third, we could use these materials to create new sensors that can detect changes in the speed of light passing through them, which could be used to measure things like temperature, pressure, or the presence of certain chemicals. Fourth, we could use these materials to create new encryption methods that are based on the speed of light. Since the speed of light is constant in a vacuum, it's used as the basis for many of our timekeeping and communication systems. However, this also means that anyone who knows the speed of light could theoretically hack into our communications and steal our data. By creating new encryption methods that are based on the variable speed of light, we could make it much harder for hackers to intercept our data. Fifth, we could use these materials to create new displays that can change the color of light passing through them very quickly, which could lead to the development of new types of virtual reality headsets or augmented reality glasses. These devices would be able to create more realistic and immersive experiences by displaying changing colors of light at much higher speeds than current technology allows. Finally, this research could lead to new ways of generating electricity. By understanding how light interacts with matter, we could develop new solar cells that convert sunlight into electricity more efficiently. This could help us meet the growing demand for clean energy around the world. Overall, this research has opened up a whole new world of possibilities for using light to improve our lives. Who knows what other innovations we'll come up with once we understand this better. Well, folks, that's a wrap on this episode of C-Show. Thank you so much for tuning in and watching. We really appreciate your support. Don't forget to subscribe for more updates. As always, thank you for watching.